Hello, welcome to section 6 of our course, the Java Collections Framework. In this section, we will be talking about collections, that is, lists, set queues, heaps, and stacks, followed by which we will talk about iterators, and we will end this section by talking about maps. This video is about collections, and that is, lists, set, queues, heaps, and stacks. In this video, we will introduce collections in general. We will talk about the characteristics that one must consider before using a collection, and we will look into the main classes and interfaces as we look into examples for each. Let's get started. A collection is a structure that is intended to store objects. Collections offer functionalities to add and remove objects to the collection dynamically. That is, a collection doesn't have a fixed size. We could add objects as much as we have available memory. Collections offer the possibility to search for objects in the collection, gain access to an object from the collection without removing it, and iterate through the collection, accessing objects in a specific order. Among the methods the collection interface declares are naturally add to add an object, remove to remove an object, contains to test whether a collection contains a specific object, size to acquire the size of a collection, that is the number of objects within it, and iterator to iterate over the objects of that collection. Please note that it is possible to iterate through the objects of a collection in a sequential way or in a random way. The characteristics to consider when choosing a type of collection. The first one is whether or not the collection is ordered. An ordered collection can be iterated through in a non-random order, based on the index, for example, or the insertion order. If the index is what is considered, objects will be associated to an index, and this will yield an order. If the insertion order is what is considered, then the objects will be ordered according to the insertion. The second characteristic is whether or not the collection is sorted. A collection that is sorted is a collection with an order based on code, and this code considers the state of the object, or in other words, the content of the object. The code can be provided by either having the class that is stored in the data structure, or in other words, the collection, implement the comparable interface. I'm going to say this again. If the class that is being stored in the collection or the data structure implements the comparable interface, we have a way of sorting objects. Another way of sorting objects within a collection or a data structure is to provide that collection with an implementation of the comparator interface. There are two ways to sort objects in a collection. The first one is having the class that is stored, the objects that are stored in the collection, implement the comparable interface, or by providing an implementation of comparator given to the collection. This will be clarified as we will look into examples. The linked hash set, for example, maintains the insertion order. The array list uses the element's index and allows you to select and set an index when you are injecting an object in an array list. A tree set, however, is sorted. Elements are ordered according to an implementation of comparable or comparator. So the order of objects changes as the developer adds and removes elements. Linked hash set and array list are ordered. tree set is sorted. Concerning main classes and interfaces. The main interfaces are set, list, and queue. They all extend the collection interface. List. In a list, objects are stored under each specific index. In a set, objects appear only once. In a queue, objects are arranged in a specific process order. Set, list, and queue all extend the collection interface. Let's get started with lists. The array lists implements list. The vector structure also implements list. The stack extends vector. Let's consider an example for each of those types of structures. Keep in mind, a list conserves the index of an object and has a set of methods related to indexes. The list implementations are array list, vector, linked list. These are ordered by index position. Let's get started. The array list is, as mentioned, a dynamic size array. It offers fast iteration and fast random access. It is an ordered collection naturally by index, since it is a list. It is not sorted. Consider two instances of the string class, S1 and S2. We create an array list that will contain objects of type string, and we inject S1 without specifying an index, and S2 twice by specifying the index. Please note that an array list, unlike a set, will authorize you to inject an object more than once. Let's run our code and consider the behavior of an array list. The first element in the list is S1. Well, simply because we have first injected S1. The second element in the list is S2. While injecting S2, we have specified the index 1. That is the second element. The first index of the element S2 is 1 because we are offered the capability of acquiring the index of an object. And the last index of S2 is 2. The array list contains S1 is true, so we output to the console that the array list contains S1. Please consider the methods we have used. Add with an index, index of, last index of, and contains. Let's consider now vectors. Vectors are similar to array lists, but they are synchronized. That is, they can be accessed by several threads without yielding an inconsistent state. They are thread safe. As being synchronized, they are naturally slower than an array list. They are ordered by index and not sorted. Consider the creation of a vector that will contain objects of type client. As you can see, we can add objects and add objects by associating them to an index. The first element of our vector is C1 simply because it was injected first. It will naturally acquire the first index. C2 was injected with the index 1. It is the last element of our structure, as we have only 2 elements in our structure. Consider the use of first element and last element. The last index of C2 is 1, as it only appears once. please consider the use of last index. Again, a vector will allow you to test for the presence of an object by using contains. Our vector contains C1. Let's consider now the stack. The stack extends vector. It implements a last in, first out behavior, as the word stack would naturally mean. It is synchronized, as it implements vector, and so it is slower than an array list. It is an ordered collection by index, since it is a list, and it is not sorted. Let's consider a piece of code. We push into the stack C1 followed by C2 and then C3. We are allowed to extract objects by index, since we are a list. Let's consider now the order in which they have been injected. We have injected C1 followed by C2 and C3. So the next element to be available and made available by this stack is C3y, because a stack is a last in, first out, or LIFO structure. Please consider the use of peek that allows us to look into what the first element of the stack is without extracting it. Pop will extract one element from the stack. As opposed to peek, it will remove an element from the stack. And so the next available element is C2, because now that C3 has been removed, C2 is the last element that was put in, and so will be the first element that will be yielded by peek. So the next element after removing C3 is now C2. Let's consider now set. Hash set is a structure that uses hash code to store objects into buckets. A linked hash set adds a link between the objects stored in a structure. A sorted set is a set that implements a sort order. A navigable set implements the possibility to navigate the data structure, and a tree set implements a navigable set. Let's consider a piece of code. Always keep in mind, sets do not allow objects to be stored as duplicates. In a set, every object appears only once. This behavior relies on the equals method to establish that objects are duplicates. In this piece of code, we will be using objects of type client, and we have made sure that client does implement the equals interface. We have provided the client class with the equals interface based on the ID of the client. After creating 3 instances of the client class, or 3 client objects, we will start looking at hash set. A hash set is unsorted and unordered. It will use hash code and the principle of storing objects into buckets, depending on the hash code associated to each object, with the intention of accelerating the extraction and the finding of objects. As you can see, we have created a hash set structure that can contain objects of type client. After adding 3 objects to that set, we consider the size of the set, we consider the possibility to add a duplicate of an object, and we remove 2 objects from that set. We test whether that set still contains C3. Let's run our code to consider the behavior of our structure. We are not allowed, as you can see, to add duplicates of an object to that structure, to a hash set. remove will yield true when the removal of the provided objects succeeds. So we have removed C1 and C2 from our hash set. Our hash set still contains C3 as the output to the console witnesses. Let's consider now a linked hash set in which objects are linked to one another. Why do we consider linking objects to one another? Simply because it provides a faster iteration. Let's get started. After adding our 3 objects to our linked hash set, we consider the size of our linked hash set, which is set to 3. We are not allowed to add duplicates of C1 to the linked hash set. As mentioned, by acquiring an iterator of type client, we can iterate through the elements contained within our linked hash set, and this iteration will be enhanced in terms of performance because objects are linked. Let's consider now the order in which our objects appear. The first element in our linked hash set is C1. Should we change the order in which objects are being added to our linked hash set, we will affect the order in which they appear. Why? Because the order implemented within a linked hash set depends on the insertion order. So now the first element is C2, as it has been injected first. A linked hash set is ordered, and the order is according to the insertion order. Let's consider now the tree set. The tree set is sorted, so the order in which objects appear depends on code we have provided. Now, please note that the client class has provided an implementation to the comparable interface, and it has as such implemented the compare_to method that will be used within a tree set to establish the order of objects. After adding 3 elements, 3 objects to our tree set, we consider their order. Let's take a look. C1 appears first in our tree set. If we change the order in which our objects are injected, we will note that the order did not change. Why? C1 is still the first element, regardless of the fact that it has been added after C2. This is because the order in a tree set depends on code, namely the implementation we have provided in the compare_to method. A tree set is a navigable set. It will give us the possibility to navigate in our tree set. For example, we can acquire the object that is lower than C2 and test whether that object is C3. We can also acquire the object that is higher than 3.2. Let's consider the output of this piece of code. The element lower than C2 is C3. This test yields false. If we test whether there is an element higher than C2, it turns out to be C3. Please consider and take time to explore more of these methods that allow you to navigate a tree set. The following tree set we are creating is not relying on the comparable interface implemented by client, but on a comparator interface implemented by client comparator. As you can see, we pass on an object of type client comparator to the tree set. Please consider that the order, one more time, does not depend on the order in which we inject the elements, but rather on the implementation we have provided in the comparator and the content of our client objects, namely the ID field. Let's consider now the queue interface. The queue interface is implemented by the linked list structure and the priority queue. Please note that the linked list structure implements both list and queue. Let's consider examples. Keep in mind that a queue is intended to contain a list of tasks to be processed. So every object would represent a task. A priority queue is intended to create a priority in, priority out structure. Elements are ordered and sorted, and so they have a priority. Elements of the priority queue are ordered according to a natural ordering, and that would mean the objects would implement comparable, or an external ordering, an implementation of comparator. A queue is characterized by a first in, first out behavior. Consider our three clients. After creating a priority queue that contains objects of type client, we add our three clients. Please note that a queue will not block us from adding duplicates. Let's run our piece of code and consider the output. The next element in our queue is C1. Why? A queue is a sorted structure, and as C1 was injected first, C1 is the next element in our queue. A queue implements a first in, first out behavior, and C1 was injected first. If we remove one element and we test what is the next element in our structure, it will turn out to be C2, simply because C2 was added after C1, and it is now the first in element as compared to C3. Let's consider now a linked list structure. In a linked list, elements are linked to one another. This allows us to remove and add elements at the beginning or the end of the structure. It is convenient for implementing stacks and queues. It will iterate slower than an array list, but it will implement faster insertion and deletion. Why? Because objects are linked to one another. As a linked list implements the queue interface, it will allow us to peek into the next object, call, and offer. Let's consider a piece of code. After creating a linked list, we inject C1, C2 that is injected first, and C3 that is injected with the index 2. And so, the index of C3 is 2. The index of C2 is 0, as it has been injected at the first position. Should we clear our list and not interfere in the way we have injected the elements? C1 is now the first in. So, the next element would be C1. If we extract one element of our queue, the next element will be C2, as it was injected after C1, and C1 has been removed, so now C2 is the first in. In this video, we have looked at collections. We have introduced what is a collection, we have talked about the main characteristics of a collection, and we have considered the main classes and interfaces and an implementation for each, if not most of them.